Algebra 2, Lesson 8.6. We're continuing and reviewing, actually, what logarithms are. And every log has a base. What you're going to see is that the common log is base 10. We work in the decimal system. So the log base 10 of x actually is just going to be expressed or written as the log of x. You're going to see that we don't have a base down here. When it's not written down there, that's going to be understood to be a 10. Likewise, there's also the natural log. That's base e. E is about 2.7. So this log base e actually can be written in a different way. Rather than writing log base e, we write ln of x. And we're going to real quickly have some review because logs are new. The first time a student sees log base b of y equals x, they can very well wonder, wow, what is this all about? Remember we said the log circle is a way to help you. The log circle is saying that this equation, this logarithmic equation, could be written as b to the x equals y. And of course, we can go bidirectionally. We could have started with b to the x equals y, and then we could write log base b of y equals x. You're going to notice I've highlighted b in green. The base of the log is the base of the exponent. And that I hope you can see in green. So that's hopefully going to help you out. The actual power, the actual exponent, never goes inside the log. It's actually equal to the log. So let's take a look at example 1. It says write as a logarithmic equation. We have e squared equals y. And the base of the log, like we said at the top of the screen here, the base of the log is the base of the exponent. Well, the power, the exponent, is a 2. You can see that. The base of that is e. So we really are going to write log base e. Now the 2 never goes inside the log. It's always equal to the log. The last piece of the puzzle is this y right here. And you can actually do a quick check that you're correct by doing a log circle right now. This should be written as e to the second equals y. So log base e is really ln. So we have the ln of y is equal to 2. Let's take a look at 1b. This ln of x, well, it's really the log base e of x is equal to 7. Remember, that's what ln really is saying. And we now want to go and write this as an exponent, so we can make a log circle. We can say e to the 7 equals x. With our log circle, and we are done. That's the exponential equation. You'll have problems in ALEKS where you will more or less do exactly what we're doing here. Here's another problem. ln of x equals 5. Well, we're going to write this as an exponent. This is a base e, log base e of x is equal to 5. And to get to the exponential equation, we're going to make ourselves the log circle. E to the 5 will equal x. Our last one of this type, rewrite as a logarithmic equation. Well, I don't have a log circle to start off with, but my base is an e. That means the base of my log is an e. My power is a y. Never put your power inside the log. Your power is equal to the log, or you could even say your power is the log. The 3 we can put over here. Now log base e, of course, is really ln. So the ln of 3 is equal to y. All right, well, the properties of logs. There are 3 of them that we'd really like to highlight. The product property, if you're adding 2 logs, here we have number 1. If we're adding 2 logs, that's log base b of m plus the log base b of n. You may combine them, you may condense them into one. That's the log base b of, and now you can multiply their insides, m times n. Look at property number 2. If we had the log base b of m minus the log base b of n, that would equal the log base b of m divided by n. A subtraction always is going to allow us to combine the 2 logs and divide the arguments. The arguments are the inside parts, so I'm putting stars by. And then if you ever have something out in front of a log, a coefficient, you can bump it up, you can raise it up high as a power. And of course, you can see as I went over here, you could also go in reverse. You could write the right side on the left and the left side on the right. It's the same basic concept. But here are some problems that you can more or less take a look at. For letter A, for number 3, fill in the missing values. Well, I hope something really, really jumps out at you. You can see that you've got a minus right here, and my goodness, that's going to be property number 2. And guys, property number 2, I'm going to write this off to the side. It's the log base b of m minus the log base b of n equals, well, I can move this over just a little bit, log base b of m over n. That means right here is m, right here is n. You would expect to see m over n, wouldn't you? Your m is the 7. If we jump back over here, your n is the 5. You'd want to have 7 over 5. And guys, that's what you're going to type in inside of this missing puzzle. As we take a look at B, I hope you can agree that because we have a plus, look at number 1 up here, that's really what we've got. And we're going to say this problem is log base b of m plus log base b of n equals log base b of m times n. Now this is looking a little bit different. And it's looking a little bit different because, here's your m, here's your n, and here's m times n. I think everybody sees that this is 3, but you don't see, look on this right-hand side, you don't see literally 2 numbers multiplied together. You know that there are 2 numbers that multiply together. You know that your n is a 3. Your m, you don't know, but together this has to be a 12. M times n is 12. You can see that right over here. So 3 times something is 12. I hope you can agree it's going to be a 4. And that's what you're going to type in to that box. Then when you're looking at part C, right here, that's property number 3. That's, your C log base b of a equals log base b of a to the c. You're going to have your 2 here, and here's a 2. So what's going to happen? You have to take that power and raise it up. This is going to become log base 3 of 2 to the 2. That number in front becomes an exponent. And what is 2 to the second power? 2 to the second power is 4. So that's what we're going to have in here. Don't leave it as 2 to the second. Simplify it. Well, let's take a look at number 4 quickly. With the addition, I hope you know it's log base b of m plus log base b of n equals log base b of m times n. So my m is here is 7. My n is a 5. Well, what's 7 times 5? You're going to multiply those two together. 35, right? 7 times 5 goes right here. Number or letter B, we'd have log base b of m minus log base b of n equals the log base b of m divided by n. Now, I hope you can see your m is a 7. And this is your m over n. That's a 7 over 3. You now know that your n has to be a 3. And that's what you're going to have to type in to your little box there. Finally, what you're going to have is for letter C, it's that third property that says, hey, you can take that coefficient, the number in front, and raise it up as a power. So look at this. If we've got negative 3 log base 7 of 2, this negative 3 is going to get lifted up as a power. You'll have 2 to the negative third power. Now 2 to the negative third power, you can do pretty quick. You can say 2, raise it up negative third. You get 0.125, but that is 1/8. 2 to the third is actually 8. The negative means take a reciprocal. So this thing right here actually is a 1/8. That's what we're going to type in right here.